Hello there. In this video, we will be continuing on with our tutorials with the QPython package. And in this particular video, we're going to continue on with the theme of how to simulate for a specific number of customers having some condition being met as they go into or out of the system. And to even more specify for this video, what we're going to look at now is simulating until a specific number of arrivals of customers have occurred in the system, which is to say that maybe you want to make sure you're accounting for some minimum amount of demand, and likewise compared to the simulating until some maximum amount of time. Simulating until you get some number of arrivals in the system does not tell you when that will occur. So the end time of this simulation approach is a random variable, but the number of arrivals into the system is going to be a constant. Okay, so let's import the QPython package. Let's define a network. Go q.create network. And we'll specify some arrival distribution. Go rate of 10. And service distribution is done. Now we need to specify some number of servers. Let's say 1. And let's set a queue, caps lock, a queue capacity of 3. Okay, so now we're ready to start making a simulation. Let's go set our pseudo-random number generators to some particular state. We'll call it state 1. We need to define a simulation object, and to do that, we'll go simulation or q.simulation, and then pass in our network that we defined above. And then just to, let's see, we'll add the records as well. And go, so after the simulation has, oh, no, sorry, we need to run the simulation next. So let's go simulate until maximum customers, and we can go 30 as we have in earlier videos. And now, instead of saying complete, which is the default, instead of going finish, which is what we did in the last video, now we'll select arrive for the number of arrivals into the system. Now let's get all records. At this point, the simulation will have run. And let's grab some information. So we know that the maximum number of customers arriving into the system should be exactly 30. But we also know that there could be, because of this queue capacity issue, there may be rejections where a customer attempts to enter into node 1 and fails to do so, so you can get rejections. So let's capture that in the form of some list comprehensions. Let's break this down into a partition. So R, where R is short for record here, R for R in records. If and only if, or if record type equals service. We know that some of them are going to be due to service. We're really just trying to create a partition here of the different possibilities. Another one is if I go sim.nodes, and this is not out of the records object per se, but if we grab all individuals, that's another thing that we can look at for comparison. And then another one, back to list comprehensions from records, is we can go record for record in records if r.record type is equal to rejection. So it says I did not close something. That appears to be closed. That also appears to be closed. Let's see what error I get if I try to run this. Syntax. I did it again. I did this in an earlier video. It's just that early morning brain fog, you know? Okay. And it doesn't say. Okay, so the simulation runs. It is giving me a typing error, but all individuals is in fact going to be an attribute of nodes 1. It's just that the type checker or the LSP is not going to detect that that thing will exist, just purely on the static analysis. Okay, so maybe we'd actually like to print this instead of just calculate it, so we can see what we're creating here. And there's a partition for us. So we've got, this should add up to 30. So 18 plus 4 is 22, and then 22 plus 8 is 30. So that makes up the sum total of all of the arrivals were either served, or they're amongst the others that are currently in the system, or that they were rejected. Now, this is a simple example where there's only one node, and so we can kind of equate record types to the number of customers. Otherwise, there's some more complicated calculations you have to do to nail down exactly what the number of customers were in the system, when a customer may go through multiple nodes or may revisit the same node multiple times and stuff like that. But in this simple example where there's really only one place to enter and then exit, it works as a simple calculation. So with that, you have now seen how to simulate a specific number of arrivals into a queue simulation. And with that, I hope to see you in the next video and enjoy the rest of your day. Take care.